Sorry, guys. Okay. My microphone was cut out, but I'm glad I caught that. Anyway, we should be up and running here. Anyway, I was showing you some of those ladybugs, and I've got that. Let's see. See that right there? Maybe one of you guys can identify those. We've been kind of swarmed by those. Those might be those Mexican bean beetles or Asian ladybugs, or we don't know. If any of you guys know, let me know. Let me feel free to post in chat. Anyway, we did have some Stratocumulus out there, and let me show you that real quick. I was running that. There we go. And these bases were up at about 4,000 or 5,000 feet. We're kind of back behind the frontal boundary. And those have been out there most of the day. And what's causing that? Well, we've probably got a little bit of low-level lift, a little bit of moisture. We tend to have relative humidities running a little bit on the high side this time of year. And maybe we can look at the isentropic charts to find these, because this is where the isentropic charts really excel. But this is the WMO Cloud Atlas site. You can see the link right there. I've mentioned this a few times over the past couple weeks. And what does the entry look like for Stratocumulus? Well, here's an example. This is a really neat atlas, volume 2, and it's in those links. Low cloud number 5. That's kind of what we have out there. So that would have the standard symbol of this. You've probably seen that. And anyway, this is a pretty neat atlas. I recommend checking this out, because this kind of factors into being able to interpret what's happening on the soundings and the upper air charts. Okay, we'll look at the isentropic analysis real quick. And when we're in adiabatic conditions with no strong surface heating or anything like that, the parcels will probably, or will tend to follow the isentropes. They'll stay on, like in this case, if a parcel is on the 298K surface, they're going to tend to stay on that surface. So how high are these Stratocumulus clouds? Let's take a look. I'm going to pull up the sounding for Fort Worth. And we don't really see the Stratocumulus on here, but we can get an idea of which surface it's on. And that's going to be up in this level. So if we follow that down, that's going to be roughly at 1,000 millibars. That's going to be about 23 Celsius, which is going to be about 296 Fahrenheit, or 296 Kelvin. Fahrenheit, that would be bad news. So we'll check the Collège du Page isentropic analysis site, 296. I'll pull that up here. And we can look at the height in terms of pressure on these black lines right here. So the 296 surface is going to be 750 millibars over West Texas, which is going to be about 11,000 feet, and a lot lower in East Texas, because this is all cold air and this is all warm air. So let's see here. This is about 925. We're going to have to go up a little bit higher, so let's go up to 298. Probably still a little bit low. 300. What do we got here in North Texas? 750. Yeah, that's about in the ballpark of what we want for the Stratocumulus. So this chart or that chart. So what's happening is you can see the wind flow is parallel to these height contours, which means if we have the tiniest bit of upward motion, and if we had low-level moisture, they would ascend that surface. And I'm looking at the charts, and I don't see much cyclonic curvature here. So there's a possibility that these clouds may be convective. They may be forming from surface heating and rising and spreading underneath this inversion. So I didn't watch these clouds form today. I don't know how they got started, but that could be where they came from. So let's see, Arctic air. I mentioned that on the headlines, and I sent out a Facebook post about that. Let me look through the chat here before I get into that. Alexi says it's the Asian lady beetle. Yeah, nuisance. They do make kind of a noxious thing when you rub them. Tornado warnings in Alabama. We'll check that out. Okay, let's look at the Arctic air, because we've got that coming up. Let me show you. Let me give you a sneak peek. This is the GFS forecast. And this is for Wednesday. I'm going to run this up to December. 1st, 2nd, 3rd of December, 4th December, 5th December, 6th December. Okay, now we're out at about 180 hours. So the GFS should have some decent accuracy out at this point. And we can see, looks like the main surface front might be down there, maybe an inclusion up into Texas, but it looks like a lot of cold air up to the north. And we can see that that's going to, look at that coming down, very strong gradient in Kansas. And we bring the 540 line, thickness line, all the way down to Waco in East Texas. And you can see GFS is hinting at some snow around December 8th. In Oklahoma, this is all wraparound, and into Arkansas. And 510 line coming all the way down to Nebraska. So, and I mentioned yesterday how the CFS model, of course, that's very up in the air, but it was also bringing some strong Arctic air about a week after this. So we're going to be dealing with this. I was looking at some Arctic outbreaks using my Argon system. I'm not trying to hawk this system because this is coming from the daily records, and this is under contract. I can't sell this into July, but I can give you kind of a sneak peek at what I'm doing here. What I did is I set up a query for what days in history the high temperature in North Texas was under 16 degrees. So I did a query, and these are the dates I came up with here. See if I can get my cursor back. Hang on a second. Okay, I'll just have to point. It's not playing with the DOS window very well. So the coldest day in Texas as far as afternoon highs, that was in 1989, December 22nd. We had a high of 13 in Dallas. And the next coldest day, that was the outbreak of 83. Some of you old-timers may remember that. We had a long period of sub-freezing weather in Oklahoma and Dallas. And then 62, that was the next coldest outbreak, just January 10th of 62 there. And if anybody remembers the 1918 outbreak, let me know. I'll have to drink whatever you're drinking. Let me pull up the maps for the 89 outbreak. These are the daily weather map summaries, and I'll show you where to get this. This is from the NOAA Weather Map Rescue here. They did a good job pulling all these old maps together and scanning them. That's going to be at lib.noaa.gov. And they've got daily weather map charts, and you can pull out maps going back to the 1870s. So the outbreak in 89, this was the single coldest outbreak in Texas and actually much of the Central Plains. So why did this get so cold? Well, what helped is this was a very fast-moving outbreak, and it did not really have time to modify. If we go back to the 19th and 18th, we can see that there was kind of like a preliminary wave of cold air that got things chilled, and we go forward and we can see that move down through Texas. Highs, let me zoom in. I can't read these numbers. Okay, so let's see here. Highs, 36 in North Texas, 29 Oklahoma City. So this isn't too bad here, but definitely very cold weather that's chilling the ground through the Central Plains. And then we move forward to December 20th. Here comes the coldest part of the cold air mass. And we can see minus 38 in Bismarck. That's not wind chill, that's air temperature. Minus 39 at Swift Current, Saskatchewan. Minus 17 at Des Moines. And minus 12 at Rapid City. And it's coming through Oklahoma City here. They're only down to only till 11. But the bulk of the cold air is on its way. And let me show you the upper air chart. That's what we're looking at 500 millibars. We need to have a very large, strong northerly component into the plains, or we're not going to get Arctic air. And also what helps is a fresh layer of snow over the northern plains. So let's see, I don't really see, can't really see the snow depths here too well. Yeah, that's all 1 inch of snow. And then we have 6 inches through here, so that's going to also keep the air mass from modifying. So those are some good things that you want to have set up before the cold air comes down here. So we move forward to December 22nd, and let's see what kind of weather we got in North Texas. -3 in Oklahoma City, and then 7 in Fort Worth off to the bottom there. So there you go. That's the coldest day. Let me check what day that was. The 22nd. Okay. And what do we have for highs and lows? There we go. 14 for a high there at, that's probably DFW Airport, and 4 in Oklahoma City. So yeah, this is some very cold weather. And then we'll look at the 83 outbreak just very quickly. Very similar pattern, cold air coming down from Canada. And let's see here. Yeah, the Deja Vu window is not really responding. Deja Vu, not exactly my favorite format for storage, but you can see definitely a similar pattern here. See the jet? There it is. And you can see there's a strong northerly component in northern Canada too, so we're pushing air off the polar ice pack into southern Canada and into the central plains. This is kind of a, especially when you have a lot of air moving out into the western U.S., that will mean an extended period of cold weather for the central plains. Okay, I think that window's out to lunch, but anyway, you can check out some of those outbreaks if you like, and if y'all have a request here, if you want to see the coldest day in your area, post in chat, and after we're done, I'll pull up a few of those. And it's going to take too long to order them, so you order them by temperature, so you might want to let me know what temperature we need to be looking for in your area. So we'll do that a little bit later. Okay, current weather. Let's take a look at that. Okay, upper level chart. Do we have that strong northerly component? We kind of do. So that's one thing that could favor some cold air generating in the northern plains right now. So what are we looking at for the next few days? Let's see here. The northerly flow kind of diminishes, and we've got this cutoff high in northern Canada. So this is not going to be favorable for cold air to come down. We've got mostly a Pacific flow coming off the west coast right there. So just moving forward very quickly through December 2nd and December 3rd. Looks like a period of very progressive systems coming out of the Pacific. And we can see that a lot of the stronger flow diminishes in northern Canada, which is important because if they've got fresh snowpack, that's going to help generate cold air in that area. So we could see temperatures starting to fall in this area. So things stay pretty busy down in the lower latitudes, and now we're starting to build up this ridge. When we have ridging in western Canada and the southeast Alaska area, that's what can help push the jet northward and kick cold air southward. So that might be a little bit what's happening here. That's not going to be very deep as far as an Arctic outbreak, but we can see late in the period, December 11th through December 12th, one of the main polar vortexes gets established over Canada. So you see the pattern we have now. That's sort of a polar vortex system over Canada. And so instead of being centered over Russia, looks like we've got a little bit of the action here now. So we'll kind of keep an eye on that over the next several days. So let's head into our forecast and see what kind of weather is going to be going on. Set this back to tonight's weather. Oh yeah, somebody mentioned we do have some severe weather in Alabama, so we can check that out real quick. I'm going to use the College DuPage analysis site. That's at weather.cod.edu, and they've got some pretty cool analysis tools you can use. And right now we're looking at the composite. No, this is the base reflectivity here, 1 kilometer. 1 kilometer mosaic. I guess they're using the lowest level scan on all the radars. But yeah, we got more development out in Mississippi, so I think we're getting kind of a reinforcing shot of cold air into that region. That front that came through yesterday, it mostly moved to the northeast and did not make much headway south, so that tends to keep a lot of the low-level moisture in place down to the south, down in this area here. So that's probably what's happening there. We can go to the SPC mesoanalysis page and see just how much moisture is down there. And one good thing you can look at, obviously dew point. I know a lot of you are interested in the SPC mesoanalysis page, so I'll show you how I do this. One way is you can go to temperature, wind, dew point, and this will show the dew point field overlaid here as contours. So basically the moisture axis is located right in this area over Alabama, and that's helping to feed a lot of this convection. And another way we can do this is by using mixing ratio. That tends to be sensitive to higher values of dew points, so this can also be very helpful aloft if you have a source of upper air mixing ratio. I use those charts whenever I can find them. And let me show you one little website that does have that. I don't know how many of you use UCAR. This was a pretty cool website back in the 00s. It's not used so much now with all these cool Web 2.0 websites, but can't even get it to respond here. Okay, let's see here. Forecast. I'm going to switch over to upper air and see if I can get that chart there. No, we can't. Okay, their model data is not really responding here, but they do have one panel there called the 925 and 850 mixing ratio, and you can use that to get an idea of depth of the moisture field. Okay, and then we'll just take a quick look at the CAPE. We're not going to use surface-based because we don't have a whole lot of input from solar heating. What'll probably be good to use here is most unstable, so if there's any elevated convection, that'll pick that up also. So 1,000 joules per kilogram over Mississippi, and 500, which is like marginal for severe weather up in northern Alabama. And then we can take a look at the 0 through 1 kilometer SRH. And that'll give us a good idea of the shear. So here, good storm relative helicity in northern Alabama. Anything over 200 to 300 is concerning. So what we have here is a high shear, low CAPE situation. And those can be some of the most difficult ones to forecast. So you have to keep an eye on these cells when they're isolated, and just keep track of the trends and make sure you don't have any surprise development on you. So let's go into the forecast here, and after that we'll look at some of the coldest outbreaks for your area. So you might want to get your requests in. So let's set this on tonight. This is thanks to Pivotal Weather for these maps here. We're showing the remnants of that front pushed all the way down into the Gulf Coast. So there it is. And that's mostly, we're seeing most of the moisture concentrated out in this area. So if you're joining us tomorrow, that's going to be on Wednesday evening. We're going to have high pressure over Texas. Looks like another kind of stagnant day. Very strong cold air advection into the Midwest. A lot of the storm activity will be moving into Georgia and Florida. Then going ahead to Thursday, when we do the webcast there, now we've got high pressure covering the southeast, starting to dry out here, but now we're seeing warm air advection coming into Texas. And we've got probably a warm front down to the south. So you kind of have to read these things into the charts to know what's going on. So we've got a warm front to the south. We know what that means. If we have any humidity, any decent humidity, we're going to get clouds and precip out of that. So we're going to watch this area setting up as we get cyclogenesis out to the west. Friday evening, now we're starting to break out the precip. Warm front probably located something like this. And then going into Saturday, now we've got the precip in full force. Then going into Sunday, looks like high pressure builds back in and starts clearing things out a bit. And now we're watching the northern plains for our next system. So going into Monday, there we go. Starting to drag some cool air southward from Canada. 540 line starting to come down. And then by Wednesday, we're looking at this for our weather picture. So is this going to happen? I don't know. We can take a look at the ECMWF. So why don't we do that real quick? Let me spawn another window here real quick, and I'll pull up the European model. And we're going to be concentrating on the, let's see, this is going to be at the 192 to 216, 204 hour point. Okay, so here comes the data. $192. Okay, so this is going to be for Tuesday morning, and then 192 for Wednesday morning. So we're going to be looking at the cold front, something like that. And this is all the data we have. Europe is not very keen on sharing model data, so we're making do with this. It's kind of a sad state of affairs, and unfortunately the ECMWF is probably one of the most sophisticated models there is. So they've really got a lock on that data. But look at that, very strong cold air advection coming in on Thursday morning. So it looks like possible blizzard conditions in parts of Minnesota and Iowa, and very cold air coming into Texas. This looks like probably a good strong cold outbreak. So we'll go back to the GFS and see if that's showing the same thing. Thursday morning. Let me match that up real quick. Thursday morning on the 8th at 12Z. Okay, looks like the ECMWF is tracking a little bit further north, but it's going heavier and deeper with the cold air advection on the backside of that system. So there are differences in the models, but both of them are painting a very potent outbreak there for December 8th and 9th. So that's going to come somewhere into the northeast or Great Lakes region. That looks like a pretty good snowstorm there for Michigan, according to the GFS. And then we clear on out, and Lee's Side Trough developing in Colorado. Now we're starting to get way out there, but looks like another shot of cold air coming in on the 13th. And looks like fun there. So looks like even more cold air up to the north. So it looks like we're finally cooling down. So that's about it for the forecast. Let me check over and see if anybody had any requests on max temperatures. And let's see, no requests. We have 20 people on, no requests for max temperatures. I'm going to do one for Denver. So let me set that up for you, and I'll let you see what I'm doing here. What is the coldest afternoon temperature we've ever had at Denver? I'm going to look at all the ones where the high was below 0. Okay, so I'm going to hit return and wait for that to put that through the meat grinder there, and wait a few seconds. If I had to guess, I'm not really sure what the coldest outbreak would be. I guess that would have to be one of the systems that I would say probably 1990, maybe December of 90. It's a good question. I don't know if there's any guesses from the viewers. Yeah, here they came. Okay, 1996 had a high of -1 in Denver. January 12th and 13th of 97, that's the next one. That didn't affect the U.S. too much, or that it didn't affect Oklahoma and Texas very much. I don't remember that system at all. February 1st of 2011 and February 5th of 2014. But another cold one that's not in here is the one that affected the ChaserCon back in 2006. February 14th, 15th of 2006. It got down to about -20 that morning, but it warmed up pretty good during the afternoon to about 5 above. So, anyway. Okay, so that's... Oh, didn't see your request. I'm sorry. Let me check here. There's a lot of text in here. I'm looking very carefully through the chat. Oh, Indianapolis. Okay, Sue requested Indianapolis. Okay, yeah, let's pull that up. And I don't want to drag this on too much longer, so I'll probably end with this one or maybe one more. I'm going to look for highs of Indianapolis of below 10. Or below 0. Or maybe we'll do 2. On this one, I would have to say that's the one... Yeah, there was a big football game back in '82, the Freezer Bowl. That might have been one of the ones. I think that was '82. Coldest day, January 20th of '85, high of -11 in Indianapolis. And then the second coldest one, that would be that December of '83 outbreak we looked at. Hit the Midwest pretty hard, too. But nothing after 1996, so... Things have been a bit warmer lately. And one request for Buffalo, and I'll end that right now. Or I'll let that be the last one right there. And I'm going to cap that at maybe -3 for the high. There's a little bit of discussion here about some of the factors that allow for cold outbreaks. I'm looking at that real quick. Lexi said Mount Washington had a high of -80 before. Not familiar with that one too well. Factors inhibiting, Victor says, and factors inhibiting major cold air is continental polar air mass source region near 25 Fahrenheit anomalies. Yeah, that's a good point there. Blue dashed lines, 940 and 924, just how cold? I don't know, I think I missed that one. Let me check here. 940, I think, is referring to the... I'm not sure what 940 is referring to. But basically, when you're talking about 500 for thicknesses, that really depends on how far north or south you are. I think we'd be talking about highs of maybe 0 through 10 degrees. If I had to take a guess. So, yeah, 540, that's going to be highs in the 30s in most places. And that's why it's associated with the cutoff for wintry weather. Not so much as a cutoff, but you tend to have wintry weather along the line and a good chance of snow north of that line. All right. So I hope that answered a lot of your questions about Arctic air and some of the outbreaks we've seen recently, and I appreciate you joining us tonight, and hopefully you'll be with us tomorrow at 8 o'clock. If there's any more cold outbreak stuff you want to see, any trivia, let me know. Post in the comments or send me an email. Anyway, thanks, and we'll see you tomorrow.